what I have here is a Raspberry Pi wireless, Raspberry Pi Zero wireless. So this is the Zero with Wi-Fi onboard and Bluetooth, which is just awesome. It makes this proof of concept, which I had the idea for about 7 years. I started executing it, creating certain pieces of it for a thermostat, just to kind of, it was a fun little project to create a thermostat using a ST Micro STM8. It was an 8-bit microcontroller. It was the cheapest development board about a decade ago. The thing was $8. Now you can get a full-fledged computer basically for $10. Anyways, it did the state machine and did a bunch of stuff for sensing temperature and humidity and figuring out like what's the comfort level and should I run the heat, should I run the air conditioner. Tested it a few times. There's some pictures. I think I have I'll put some pictures up of what it looked like. And it worked well. It had a 2x16 display. But then it was trying to get it to interface with hourly pricing. What I have here is, this thing is just waiting right now for me to SSH back into it. Okay, I need to reboot it actually really quickly. So you're gonna see it go back through its power on cycle and do some stuff with the lights. The old Raspberry Pis had just a plethora of lights. This is a Raspberry Pi Model B, I believe, that had a whole bunch of lights for, what is that, 100 meg on the Ethernet port, link, FDX, what's FDX? I think it's packet transfer, power and OK, or maybe this is the disk access, I forget. But a bunch of lights, and the Raspberry Pi Zero has one light, which is, it's fine because it's nice and minimal for the tiny little package that it's all in, but this bonnet that sits over it is actually, it obscures the light, so you're watching it to see if it's actually doing anything. And I think now it is ready. It is ready now, cool. Boots pretty quick. Now we're going to Tmux. And I need to go to root. And I believe it's in shared hourly pricing. And if we, whoops, not Python. It is Python. And there we go. So I'll execute it. It'll do, whoa. It'll do some initialization. You'll see the light cycle really quick. It's just a light test. There it goes. And it begins running, and then the display will come on. And so right now, a couple things are happening. One, as you can see in the screen grab, that it is starting the RRTP monitor. So it goes, and every 5 minutes it goes out to the RRTP site and uses the API to make a request to get the current cost of electricity. So this is the current cost right now. Now there's some details that I'll get into in the next video. I just want to go over kind of what's going on here now about what that means. But for right now, let's say that this is the current cost of electricity. And what the Python script does with that, what I wrote to do with this value is assign it to a color. It's this simple if-else-if structure for if the cost of electricity is really low, then light up the blue light, like less than right now it's, I think, less than 2.2 cents per kilowatt hour. It'll light up the blue light, meaning it's a blue light special. Go and use as much electricity as you'd like. Typically it sits in the green, which is about 2.5 to 4.5. That's that range I was talking about in the previous video. If you go above 4.5 or below 6.5, then the amber light comes on, and if you go above 6.5, then the red light comes on. And so in addition, there's a bunch of, every so often the API server doesn't want to respond sometimes, so there's a bunch of error handling that needed to be implemented to initialize some waits and then retries. And then, like any other good API implementation, you're doing, your call throttling. So I'm not just trying to hit it a whole bunch of times to try to get the update, but it will try at a rate of one try every 5 minutes, If it can't get something in 5 minutes, then it retries again after 1 minute, because you want to keep this updated. And if it's not updated and that server goes down, which it has gone down like one time in 8 months for about maybe a half an hour, then you want to indicate to the user, hey, I don't know what the pricing is. You're on your own. It's the wild, wild west, you know. So there's that. The other piece is the outdoor temperature. That's a recent thing that I added just before I started making this video. It's knowing what the outside temperature is and outside humidity is, especially as we approach summer, to get an idea of, well, what's the heat index? What does it feel like outside? And how does that translate to comfort inside? And what the potential cost impact will be when the outside temperature is high. Because when the outside temperature is high or the heat index is high, people get hot, they want to be cool, so they'll turn their air conditioning down and the cost goes up. So it helps give more insight as to what's going on here with that phenomenon. I SSH in this thing all the time. It's not exposed to the internet. The intent really is to never have anything exposed except for things that it makes calls to, and then when it does security updates and things like that. The idea for this project is to really make this be as privacy oriented as possible. There are no microphones mounted on this, haha. As well as, you know, it really being just about you having the control over what you're spending your resources on. And so this gives you more insight and better visual indication of like, oh, what is cost for electricity? Something that is very abstract. You don't really notice it until you look at your electric bill and you go, oh my God, my electric bill's $100 this month. Why? Well, this I've noticed, and my wife has noticed, that it helps get a very quick visual indication of what is going on. So the other thing that's built in is I SSH'd into it from inside. So I have a static IP, but just in case the IP changes, I included that, which is just some example code that I was playing around with. And then I also have, I'm gonna hit it one more time here so you can see it. There's also the last update. So the last update is important. So it tells you, it's not the current time, it's from the RRTP server, the RRTP server's API, the return it gives you, it includes the last time it was updated. I don't think I mentioned it, but the weather data is being provided by the Dark Sky API. I originally wanted to use the Weather Underground API, but they were acquired by IBM and became I think there's the Weather Company. I'll put it up somewhere. And the Weather Company put all of the weather API functionality behind a paywall. So that's unfortunate. I mean, if it helps keep Weather Underground around, fine, but it kind of sucks for developers like myself that just want a good, reliable source of outside weather without having to go put a weather station outside just to get temperature and humidity. I might want more things later. I might implement my own outdoor temperature sensor and weather station later, but for right now, I just want this. So the Dark Sky API, and I'll put a link to it below, allows you to, for free, make 1,000 calls to the API a day, which I'm updating it every 5 minutes, unless I manually refresh it. So that's 12 times an hour, and it's about, that's what, 144, 288 times a day. And I might actually throttle that down even more as it gets like in low demand times where we don't really care about the outside temperature. It can be 10 minutes between updates or whatever. But I'm nowhere near the 1,000 per day, so it works. The next little piece I might touch on is, so what are the next big pieces that I'll be introducing in future videos? And they involve taking this, which right now, there's no way for this thing to control anything in the outside world, or take any input from the inside to make any sort of decisions onto whether or not to run HVAC. That's the big next piece that I described in the previous video. So we need two things. One, we need relays to be driven by this thing to control the thermostat wires that are on the 4-wire system coming in from the furnace controller, which I will describe in a future video. But we need a relay module. And then the other piece is something that I'm going to sneak in here off of screen that is currently being tested using a Teensy, just to make sure that it actually is functioning properly. And surprise, surprise, it is functioning properly. This is not going to stay. I put the pins on. This is a hasty setup for this thing when I bought this Teensy a while back, and I actually put the pins on the wrong side. So instead of being able to push it down into a breadboard, they stick up. One day I'll fix it. But this is going to be the inside temperature, humidity, barometric pressure, and air quality sensor. It is a Bosch BME 680. This one I bought through Adafruit. It communicates over I2C, and we'll be using it to get, really right now all I need is temperature and humidity. Barometric pressure, cool. We can figure out when low pressure systems are coming in or high pressure systems are coming in, and you can also infer altitude based off of it as well, which is pretty slick. And the air quality is neat too, because you can get an idea of air quality based off of air quality index and all that stuff. But that's all future stuff that'll be in way future videos, or maybe sooner depending on what I want to play with. But this will be the temperature and humidity sensor on this device, and that is the next piece to be implemented on this. It's already being tested and working on the Teensy and has been calibrated, and a few other things that I've worked out as far as how to actually best provision it, and then it will be rolled into this. And beyond that, the other thing that's a little longer term, but it's a pretty cool addition, is another thing I picked up off Adafruit, which I just want to show right now. But this will be tested on the Teensy and probably will not be used for a little while. But it is a display that I think will be in the prototype, which will be all these things kind of disassembled and taken apart and packed into a 3D printed enclosure that will snap onto the wall or be near where my thermostat is to replace that functionality. And this is the SSD, it's a 1.5 inch color OLED display, 128 pixel by 128 pixel, driven by the SSD 1351 chipset. And so this has beautiful color, and I'm kind of excited about that because I'm debating whether or not I want to keep this function. I mean, obviously, this is not going into any sort of prototype. This is just, I wanted to build a little board, as you can see here. And it'll either be condensed down into a single RGB LED that, you know, provides various indications, or it'll be a color on this display. Further down the line is interfacing this with an iOS or an Android app to give notifications and to control it remotely from iOS and Android devices. So that's the project as it stands right now. I hope you enjoyed this video, and in the coming weeks this is going to be more and more in-depth things as I'm working on, what issues I've run into, and yeah, I guess the long view for this, I really don't know where it will go, but eventually the intent is to take all the modules, build a printed circuit board, lay it out. You guys can follow me through that process as well. The schematic layout, the trace layout, get a printed circuit board, put all of this together on it. Whether or not we retain the Raspberry Pi W as the core, or look for something lower power, I don't know. But this is the proof of concept. This is just to show that it can work, turn it into a prototype, and this is how kind of potentially a product is born. So I really wanted to do it this way. I wanted to do it where I was showing it as opposed to it being something that's like, here is the thing and I'm done. But I hope you like this video. Please give it a thumbs up if you did. Please click that subscribe button so I can continue to grow this channel and provide more videos like this. Thanks, and I'll see you in the next one.